Hello, everybody. Today we're going to talk about applications of circles. Okay, so Maria wants to plant all 50 of her prized petunias around the edge of a circular garden. Each flower needs to have 8 inches of space at the edge of the garden. Calculate how big of a circular garden she can have. What is its radius? Okay, so what are we going to have here? We've got a circle. Oops, let's put a point on here to start with. That always helps. It's always a good idea to draw the picture. So here's the circle. She needs 50 spaces around these plants. So she's got her plants spaced like this, okay? And each one of them needs to have 8 inches of space at the edge of the garden. So each one of these is 8 inches all the way around. Okay, so then we can calculate the circumference of the circle, because the circumference is going to be 50 times 8 inches, which is going to be 400 inches. Okay, so that's my circumference. Now, we want to calculate the radius from that. So we're going to want to know what is that length right there. Okay, so we do know this. We know that the circumference is 2 pi times the radius. Okay, and we know that the circumference is 400, so we can go ahead and substitute that in here. And we can solve for r by dividing both sides by 2 pi. And so that cancels out here, leaves me with r. So r is going to be 400 divided by 2 pi. So I'm going to get out my handy-dandy TI-84 plus C Silver Edition graphing calculator, and I'm going to figure that out. Now make sure that if you are doing this on your calculator, that you put parentheses around the 2 pi like that. Okay? And you're going to get 63.66 inches. So that's the radius. Okay, and there we go. All right, a tractor tire has a radius of 3.5 feet. So let's go ahead and sketch a little circle here. Okay, it's got a radius of 3.5 feet. All right, so there's my picture. What is the speed in feet per second of a point on the edge of the tire if the tire is spinning at 50 RPMs, which is revolutions per minute? Okay, so let's do this. Let's move that all over there. Okay, whoops, I lost my decimal. It looks like it says 35 feet, doesn't it? Should be 3.5 feet. Okay. So the first thing we need to figure out is what's the circumference of this circle. So the circumference, remember, is 2 pi times the radius, or in this case, it's 2 pi times 3.5, or 7 pi. Okay, and we want to work that out. So 7 pi is going to be like 22. It's almost exactly 22 feet. We're going to go ahead and round it to 22 feet. Okay. Now, if the tire is spinning at 50 revolutions per minute, okay, so in 1 minute, this is going to go 50 times. Now, this tire is going to rotate 22 feet every time it goes around once. So the distance traveled is going to be 22 times 50. Okay, so 22 times 50, that's going to be 1,100 feet. Okay, that's in 1 minute. I'm going to say per minute. Okay, what is the speed in feet per second? So this is in feet per minute. So if we've got 1,100 feet in 1 minute, we need to convert that to feet per second. So we've already got the feet in the top. Okay, so we want to convert to seconds. So we've got 1 minute is equal to 60 seconds. So if I do this, the minutes will cancel out of this thing, and I will get feet per second. So this is going to be 1,100 over 60, which is going to come out to 18.3 repeating feet per second. And I'm done. All right. When you get done with a problem like this, it's always a good idea to go back and reread the question and make sure that you answered the correct question. I can't tell you how many times I've had students who do all the math right, but they don't answer the question that's asked of them. They answered something else. So what is the speed in feet per second? Well, we've got feet per second right here. Of a point on the edge of the tire if the tire is spinning at 50. So we've figured out that point is right here, we'll say. All right, we have figured out how fast in feet per second it's going. Okay. A satellite is in nearly circular orbit 2,300 miles above the Earth's surface. All right, let's sketch a picture of this. Now, this is a picture that you got to be really careful of. Okay, so the first thing we're going to do is we're going to miss. Okay, let's move this just a little bit. There we go. This is the Earth. Now, we're going to have another circle with the same center, like so. Okay, this is the satellite. So let's just put a little dot up here. We'll call it S for satellite. Okay, and it's 2,300 miles above the Earth, so we'll go ahead and, this is obviously not to scale, but we'll say that that is 2,300 miles. Okay, so obviously this is way too big for the Earth. Well, maybe not. Okay, so the Earth has a radius of approximately 4,000 miles, so actually this is a little bit small. So if we went ahead and we put the radius of the Earth in here, that's going to be right there. Okay, and that's going to be 4,000. Okay, what is the speed of the satellite if it completes its orbit in 9 hours? So it goes around the Earth one time in 9 hours. We need to figure out what that circumference is. Okay, so let's do this. The circumference is 2 pi times the radius, and the radius is going to be 6,300 miles. It's the 4,000 plus another 2,300. Okay, so the circumference is 12,600 pi. Now, this is such a big number that it's probably a good idea to actually use your pi key to get a little bit more accurate. So 12,600 pi is going to be approximately 39,584 mile, 0.067 miles. Okay, that's what it went in 9 hours. So what we're going to do next is we're going to take this and we're going to divide this by 9. Okay, so divided by 9 means that it's going to go 4,398.23, we'll round it, miles per hour. Okay, what is the speed of the satellite if it completes its orbit in 9 hours? There we go, that's the speed. Distance divided by time. Okay, if a tire has a warranty for 30,000 miles and a radius of 10 inches, how many revolutions will it make before the warranty expires? Okay, so here's what we're going to do. We've got a circle, like so. It's got a radius of 10 inches. All right, so there's our radius. Okay, and that's 10 inches. And so the circumference of the tire, the circumference is going to be 2 pi times 10, or 20 pi. So 20 pi, whoops, not 20e, 20 pi. It's going to be 62.83. And this is also going to go into a big number, so I'm going to make this accurate by taking this out here a few decimal places. Okay, so there's the circumference. That's in inches. Now, this tire can go 30,000 miles on its warranty. So the first thing that I'm going to do, since I've got miles and I've got inches, is I need to get them in the same unit. So probably pretty hard to change this into miles, but I can change that into inches pretty easy. So 30,000 miles times 5,280 feet in a mile times 12 inches. Okay, so here we go. 30,000 times 5,280 times 12. That's a big number. Let's see, what do we got here? Okay, so that tire will be under warranty for 1,900,800,000 inches. Okay, so now I just got to take this and divide it by that. So I'll take this, divide it by 62.83185. And that comes out to we'll round to the nearest whole number. That's how many revolutions this thing's going to make. $30,252,173 revolutions, and then the warranty will be completely expired. Okay, how exciting. All right, two concentric circles have a central angle of 105 degrees. So we got concentric circles. So let's go ahead and draw that. Let's start out with this, and we'll go. There's one. There's the other, and we're off just a little bit, so let's move this. Okay, there we go. They have a central angle of 105 degrees, so let's go ahead and put in a central angle. 105 would be, I don't know, somewhere around there. So we got this nice little picture right here. We'll go ahead and put in 105 degrees right here. The inside intercepted arc has a length of 8.66 feet. So this is going to be 8.66 feet right here. That's this distance. Let's actually change this color up right here. Let's make that blue. We'll match that up blue. Okay. And then it says using 3.14 for pi and rounding to 2 decimal places, what is the length of the corresponding intercepted arc with a radius 6 feet longer than the smaller circle? Okay, so be careful of this. This right here is going to be 6 feet longer, the radius. So this part is 6 feet right here. Just that part is 6 feet. Okay. Draw a picture and solve it. So here's my picture drawn. Okay. Let's kind of group that together. Move that over here. Okay. So here's the thing. We know that the circumference is 2 pi times the radius. And we know that the blue part of this thing is 8.66, and it is 105 out of 360ths of the radius of that circle. Okay, so we're going to calculate the radius. Okay, so first thing I'm going to do, I'm going to multiply both sides of this equation here by 360 over 105. Okay, so what that'll do is that will cancel this, that will cancel this, leave me with 2 pi times the radius. All right, 8.66 times 360 divided by 105. So this comes out to be 29.69 and some change. All right, now it said to use 3.14 for pi. So that means that this is going to be 6.28 r is going to equal 29.69. So we're going to divide both sides of this by 6.28. So that's going to tell me r. That's going to come out to be 4.73. And that's going to be in feet. Okay, that's this right here, 4.73 feet. Now, the radius of the big circle is going to be the 4.73 plus 6, so that's going to be 10.73. So this is going to be the circumference of the big circle. Actually, I only want the arc. So let's do the arc here. We'll do this color. This arc right here, we'll call it A for arc length, is going to be 105 out of 360 times 2 times pi times the radius, which is going to be 10.73. Okay, so this is, we'll call it A over here. So 105 divided by 360 times 2 times 3.14 times 10.73 comes out to be 19.65, and that's in feet. Okay. So what did I do? I used this and this arc length to calculate the radius. I added the radius to the distance between the two circles. I got a new radius. Then I calculated the length of that arc right there. Okay, so there you go, 19.65 feet. All right, so I got a nice little assignment here for you. It's all story problems. So make sure you have fun with that and enjoy that. I will talk to you guys later.